Hi friend, welcome back to Raman Tutorials for GK. This is Rangaraju from Tumkuru. Dear friend, today I am going to discuss about difference between ethanol and ethanoic acid. As you know that in oxidation reaction, ethanol reacts with the excess of oxygen to give ethanoic acid in the presence of potassium permanganate or it and also potassium hydroxide as a catalyst. So in this video let us discuss about what are the main difference between the ethanol and ethanoic acid. Dear friend, as you know that ethanol, that is CH3CH2OH, so it is a molecular formula for ethanol, and ethanoic acid CH3COOH. So these are the molecular formula for ethanol and ethanoic acid. Now let us discuss about a difference between the ethanol and ethanoic acid. Now in the difference there are two parts, that is physical properties and chemical properties. That means based on physical properties how to differentiate between ethanol and ethanoic acid, and in some other case based on chemical properties how to difference between ethanol and ethanoic acids. Now let us discuss ethanol, ethanoic acids in detail. Now, now in the beginning, let us discuss about the some properties of ethanol. Ethanol having the melting point is 156 Kelvin and boiling point is 351 Kelvin. That means it is having the melting point 156 Kelvin and boiling point 351 Kelvin. Now, next point. It has sweet odor. That means the smell of ethanol is sweet odor. So this is the second point regarding to the ethanol. Now let us come to the next one, that is it has OH as a functional group, that is alcoholic group as a functional group. Then one more point is colorless liquid with pleasant smell. Ethanol is colorless liquid with pleasant smell. Now it does not react with litmus paper. Ethanol does not react with litmus paper. In other words, ethanol does not change the color of the blue litmus. So this is the main points. Then next one, it does not react with sodium hydrogen carbonate. That means does not react with sodium bicarbonate. So these two are the chemical properties, that is it does not react with the litmus paper, so it is one of the chemical property, and then it does not react with the sodium hydrogen carbonate or sodium bicarbonate. So it does not react with the sodium bicarbonate. So this is the main points regarding to the ethanol. Once again, ethanol, its melting point is 156 Kelvin and boiling point is 351 Kelvin. Then it has sweet odor. That means pleasant smell. Colorless liquid. It is a colorless liquid and pleasant smell. Then it has a OH group, that is alcoholic as a functional group. Yes. Next point, that is it does not react with the litmus paper, and then It does not react with the sodium hydrogen carbonate. Now let us discuss about ethanoic acid. Ethanoic acid, its molecular formula is CH3 COOH. Its molecular formula is CH3 COOH. CH3 CH3 COOH. So this is the molecular formula for ethanoic acid. Now this ethanoic acid is obtained by adding oxygen to the ethanol in the presence of potassium permanganate KMnO4 as a catalyst or oxidizing agent to give rise to ethanoic acid. Dear friend, let us discuss about some important properties of ethanoic acids. Now, first point is it has melting point 290 Kelvin and boiling point is 391 Kelvin. So this is the first point, that is 290 Kelvin. Melting point is 290 Kelvin and then boiling point is 391 Kelvin. Therefore, compared to the ethanol, in ethanol, melting point is 156 Kelvin, whereas boiling point is 351 Kelvin at room temperature. Now, next point, it has pungent odor. It is also a colorless liquid, that is ethanoic acid also a colorless liquid but pungent odor smell. Therefore, next point, it has COOH, that is carboxylic acid, as a functional group, whereas in ethanol it has alcohol OH or hydroxyl group as a functional group, whereas in the ethanoic acid COOH, that is carboxylic group, is a functional group. Then next point, it changes the litmus paper into, that is to red, that is blue litmus paper to red, that is ethanoic acid changes the blue litmus paper into the red. Then it reacts with sodium hydrogen carbonate, that means ethanoic acid reacts with sodium bicarbonate to release carbon dioxide So these are the some differences between the ethanol and ethanoic acid based on their chemical properties and also the physical properties. One more thing is ethanoic acid is melting point of pure ethanoic acid is 290 Kelvin. That is already you know the terms, that is the melting point of the pure ethanoic acid is 290 Kelvin, and hence it often freezes during winter in cold climates. That's why ethanoic acid is also called as glacial acetic acid. Glacial acetic acid. Glacial acetic acid. In the examination, why ethanoic acid is also called as glacial acetic acid? Give reason. Because the melting point of pure ethanoic acid is 290 Kelvin and hence it often freezes during winter in cold climate. Therefore, this type of acid is called as glacial acetic acid. So these are the some important points regarding to the ethanol and also the ethanoic acid. I think this concept will clear, that is the difference between the ethanol and ethanoic acids. Now next point is alcohol react with sodium to form a salt, that is sodium ethoxide and hydrogen gas. The reaction is similar but much slower than the reaction of water and sodium. This is because of the similarities in the structure of the water molecules and the alkyl, that is OH group in alcohols. Due to the low density of the alcohols, the sodium sinks. The reaction proceeds steadily with the evolution of hydrogen gas and leaves a colorless solution of salt. The salt can be recovered as a white solid by careful evaporation of the solution. Now, CH3CH2OH plus sodium gives rise to sodium ethoxide. So here CH3CH2OH reacts with the sodium, that is ethanol reacts with the sodium, gives rise to sodium ethoxide plus hydrogen gas is liberated. Dear friend, CH3CH2OH, it is ethanol. When ethanol reacts with the sodium, gives rise to sodium ethoxide, here Na plus, sodium ethoxide, CH3CH2O Na plus, that is sodium ethoxide, and hydrogen gas is liberated. So this is the reaction of ethanol with sodium. Once again, write the reaction of ethanol with sodium. Now, so ethanol reacts with the sodium to give rise to sodium ethoxide with the liberation of hydrogen gas. Next one, dehydration of ethanol. Dear friend, in chemistry, dehydration means removal of water molecules. That is, removal of water molecules from ethanol using concentrated H2SO4 as a dehydrating agent. That is, in chemistry, a dehydration is one of the reaction is a conversion that involves the loss of water from the reacting molecules or ion. So this is the meaning of the dehydration. In general meaning, dehydration means removal of water molecules from ethanol using concentrated H2SO4 as a dehydrating agent. That is called dehydration of ethanol. Now, dehydration reactions are common process. That means the reverse of a hydration reaction. That is, common dehydrating agents used in organic synthesis including sulfuric acid or sometimes alumina also used as a dehydrating agent. Now let us consider the reaction. Here CH3CH2OH, that is ethanol reacts with the are undergoing the dehydration process in the presence of concentrated H2SO4. So it is one of the dehydrating agent. Sometimes alumina is also used as a dehydrating agent under the temperature 443 Kelvin. So this reaction is called as dehydration reaction. Here in this reaction, ethanol going to lose their water molecules when they undergoing the heating process under the presence of concentrated H2SO4 to gives rise to C2H4 and also the water molecule is produced. So this reaction is called as dehydration reaction. First one is reactions of ethanol, that is among the reactions of ethanols there are two reactions. First one is reactions with sodium, that is sodium reacts with the ethanol gives rise to sodium methoxide and hydrogen gas is liberated. In the examination, the question is like this: name the gas evolved when the sodium reacts with the ethanol, that is the hydrogen gas. Then one more reaction, that is dehydration of ethanol. Already you know the meaning of dehydration. Dehydration of ethanol is removal of the hydrogen molecules or water molecules from the ethanol, that is CH3 CH2OH from the ethanol by using the concentrated H2SO4 as a dehydrating agent. So that is the dehydration reaction. Now next one. Next reaction is esterification reaction. Dear friend, what is esters and what is esterification reaction? Now let us discuss about the formation of esters. Now, dear friend, esters are most commonly formed by a reaction of an acid and an alcohol. That is the reaction of alcohol and acid togetherly called or togetherly obtained, that is the esters. Now in the chapter let us discuss about what is esters and how esters are formed. Now esters and water are formed when alcohol react with the carboxylic acid. This reaction is called esterification. Esterification means the water and esters are formed or obtained when alcohol, either ethanol or methanol, whatever it may be, any one alcohol reacts with the carboxylic acid to give rise to esters and water. This reaction is called as esterification. This reaction is called as esterification. Once again, esters, in the esterification reaction, esters are obtained and water also obtained. Esters means esters are most commonly formed by reaction of alcohol and also an acid. Now, this esterification reaction is a reversible reaction. This type of reaction is called condensation reaction. In examination, why esterification is called as condensation reaction? Give reason. That is, in the esterification reaction, water molecules are eliminated during the reaction. Therefore, esterification reaction is also called as condensation reactions. Now, let us discuss about what are the main conditions for esterifications. Dear friend, there are so many conditions for esterification. Now, let us discuss in detail. That is, the first point is concentration sulfuric acid as catalyst. So, this is one of the main important conditions, and also the reflex at 180-degree temperatures. So these are the important points regarding to the esterification. Now let us discuss about the equation, that is CH3COOH. So it is one of the carboxylic acid, and ethanol CH3CH2OH gives rise to, that is under the presence of H2SO4 or sulfuric acid and also the temperature 180 degree, then gives rise to methyl propanate, that is CH3C, C double bond O, CH2 plus H2O. So this is one of the esters. Now let us discuss about some properties of esters and also the examples of esters. Dear friends, esters are sweet smelling substances. Esters are sweet smelling substances. That means the sweet of the esters, the smell of the esters is pleasant smell and also sweet in smell. Then, second point, they are used in making perfumes. That means esters are used in the perfumes as and also as flavoring agents. Examples for esters are methyl propanate, ethyl propanate, propyl propanate, methanate propanate, etc. So these are the examples of the esters. I think this reaction is called as esterifications. Esterifications means formation of esters and also the waters by the reaction of acid and an alcohol is called as esterification reaction. Ethanoic acid reacts with the absolute ethanol in the presence of an H2SO4 as a catalyst to give an ester. So this is about ester. One more reaction is saponification. Dear friend, saponification is an alkaline hydrolysis of esters. A salt of carboxylic acid is formed instead of the acid. In the simplest way, saponification is a process that involves conversion of fat or oils into soap and alcohol by the action of heat in the presence of alkali, that is sodium hydroxide. So this process is called as saponification. Once again, saponification is a process that involves conversion of fat or oil into soap and alcohol by the action of heat in the presence of alkali, that is base NaOH. So this reaction, this process is called as saponification and the product obtained in this process is called as soap. Now let us discuss the saponification reaction. Dear friend, here is the one example, that is CH3 COO C2H5. This is methyl propanate. It is one of the esters. Reacts with the sodium hydroxide or alkali or base, gives rise to ethyl alcohol C2H5OH. So this is ethyl alcohol and then sodium acetate CH3COO Na plus, here COO minus and then Na plus. So this is called sodium acetate and this one is called ethyl alcohol. That means is in the process of conversion of fat. So this is the methyl propanate. It is one of the esters or long chain fatty acids. React with the alkali, that is sodium hydroxide, gives rise to ethyl alcohol and also the sodium acetate. Now this process is used in the preparation of soap. Therefore this process is called as saponification. In the examination, what is saponification? Write the equation to show the saponification process. Then soap. Dear friend, soap means soap or sodium or potassium salts of long chain carboxylic acids, that is sodium palmitate or CH3CH2 14COOH plus NaOH gives rise to CH3CH2 14COO Na plus H2O. So this is the equations for soap. Now let us discuss about the one more concept, that is ethanoic acid react with the carbonate and also the base. Now let us discuss in detail, that is how ethanoic acid react with a base. Dear friend, ethanoic acid, that is acetic acid CH3COOH, is an acid, while sodium hydroxide NaOH is a base. I think it is well known. That is ethanoic acid, it is a acid, it is one of the acid, acetic acid, and then sodium hydroxide, it is one of the base. So their reaction gives us sodium salt of ethanoic acid, sodium salt of ethanoic acid, and water also produced, and the corresponding reaction is as follows. That is, reaction with a base, ethanoic acid react with a base when ethanoic acid CH3COOH, ethanoic acid reacts with a base such as sodium hydroxide to give a salt. What type of salt? That is salt of ethanoic acid, and also the water is released. Now the corresponding equation is as follows. Here CH3COOH plus NaOH. Dear friend, CH3COOH, that is, it is ethanoic acid. When ethanoic acid react with the, this is ethanoic acid, ethanoic acid reacts with the base, ethanoic acid reacts with the base to give rise to sodium ethanoate or sodium acetate, sodium ethanoate or sodium acetate. Here Na plus, COO minus and Na plus, and also the water H2O is released. So this is the reactions to show the reaction of ethanoic acid with base. Now let us discuss one more reaction, that is reaction with carbonate. Ethanoic acid react with carbonate. Now let us discuss about ethanoic acid react with carbonate. Dear friend, ethanoic acid plus sodium hydrogen carbonate or sodium carbonate gives rise to sodium acetate plus water plus carbon dioxide is liberated. That means when ethanoic acid reacts with the sodium hydrogen carbonate or sodium carbonate to give sodium acetate or sodium ethanoate, and also water is and carbon dioxide gas is released. So the corresponding reaction is as follows. Now CH3COOH plus NaH, sorry, here Na2CO3, Na2CO3, this is Na2CO3 gives rise to CH3COONA, here Na plus and COO minus plus water molecule plus carbon dioxide is liberated. So this is the reactions to show the ethanoic acid reacts with the carbonate. That is, ethanoic acid reacts with the carbonate to give rise to the sodium acetate or sodium ethanoate. Here the balancing the equation, therefore we have to put here 2, then the equation is, and here also 2, the equation is, now equation is balanced. Now let us discuss about one more reaction, that is reaction of ethanoic acid with sodium bicarbonates. Now let us discuss. The carbon dioxide gas is produced, rushes away from the water. Now ethanoic acid react with bicarbonate. Ethanoic acid reacts with bicarbonate. Dear friend, the reactions can be explained with the equation, that is NaHCO3, that is sodium bicarbonate, reacts with the ethanoic acid CH3COOH, gives rise to NaC2H3O2 plus H2O plus carbon dioxide, or one more reaction, that is CH3COONA. This is becomes CH3COONA CH3COONA plus water and carbon dioxide is released. Here sodium bicarbonate plus acetic acid equals sodium acetate, that is CH3 COO Na. This is also one more reaction. CH3COO Na equals acid equals sodium acetate plus water plus carbon dioxide is released. So these are the some reactions to show the to to show the reactions of ethanol and also the saponifications and the reactions of reactions with the base and also the carbonates and bicarbonates. Now one more concept, that is cleaning a soap. Already you know that soap means soaps are sodium or potassium salts of long chain carboxylic acids. Long chain carboxylic acid. Example, sodium palmitate. Then one more concept is hydrogenation. In the addition of hydrogenation means addition of hydrogen to unsaturated hydrocarbons in presence of catalyst such as nickel or palladium to form saturated hydrocarbon is called hydrogenations, and this technique is used in the industries to convert vegetables oils to vanaspati ghee. So these are the some important points regarding to the these are the some important points regarding to the, that is saponification, and also the ethanol, difference between the ethanol and ethanoic acids, and also the some reactions of the ethanol with the other, that is sodium, and also the base, and also the esterifications, and also the saponifications. I think this video will help us to all the competitive examinations. So please keep on watching video. Thank you.